Welcome back to computer science. Yesterday we learned about, I don't know if it was all yesterday or the day before as well, but we'll just rip through the review. Modules and print functions, okay. Modules are essentially, a script is a document that contains Python that is passed directly to an interpreter as an input. A module is a file that contains Python that is actually imported into another module or script and is executed immediately upon running the script. Use the import statement. Module, anything else. Python standard library has a bunch of pre-built modules. __name _ basically is a value that lets you know if a file is a script or a module. If it's main _ main _ then it's a script, not a module. Okay, let's jump in. That was definitely 2 days ago, but anyway, fine. Let's jump into yesterday then. We finished up that, and then we started working with print functions. So print function, not the print function. We're talking about print functions, which are user-defined functions that only print and don't actually return a value. If a function does not return a value, then it is a void function. It returns capital N-O-N-E, none. That's a void function. Print functions can just help reduce clutter in the main program, save a lot of time and reduce errors, especially if there's multiple callings. You need to call the function multiple times. Right, using multiple modules can help make managing a large project a lot easier. Okay. On that note, I'm going to jump back into continuing learning, and I'll be back to recall what I learned today a little bit. All right, guys. So we finished up the unit on print functions. Now we've been in the unit today on dynamic typing, dynamic versus static typing. First, I was like, typing with your fingers? No, typing as an object type, like data type. So polymorphism is a inherent property of Python, meaning polymorphism means an operation that changes its behavior based on what object type is passed, such as the plus sign adding operation changes if it's strings being added together, or if it's integers or floats being added together, right? Same with multiplication, certain function, as well as any object type can be passed to a function via a parameter. Doesn't mean it will execute fully, but it can be passed. And this is an inherent property of Python. And so dynamic typing is also, it's Python. Python does dynamic typing, basically meaning that Python evaluates the type of objects and variables and parameters as it interprets the program, versus static typing, which is used by programs like C, C++, Java, where you have to declare a variable and a parameter as type explicitly every time you create a variable or parameter. And then when it gets compiled, the compiler checks for all these non-safe type operations, and it will throw error right away. Versus Python, won't until it gets there and the actual execution. So it leads to more flexibility for the programmer, but at the cost of potentially more bugs. Right, in Python, the type of dynamic testing Python uses is duck typing. Dynamic typing is duck typing. Duck typing comes from the quote, like, if it walks, talks, and looks like a duck, then treat it like a duck. That's that's as much as we got of a description of what duck typing is. It's if you can do things like slice it, index it, lowercase it, concatenate it. It behaves like a string. Treat it like a string. It is a string essentially. So you can pass any type of object as an argument to a function. Good. Polymorphism and operations behavior varies based on different object types. Good. Inherent part of Python. Good. Dynamic typing used by Python to determine type of object as the program executes. Good. Python uses duck typing, form of dynamic typing. Good. Static typing requires a programmer to define the type of every variable, every function parameter in a program source code. Good. Used by C, C++, and Java. Good. Compiler checks for non-type safe operations. Good. Dynamic testing allows for more programming flexibility at the cost of potentially more bugs. Good. So that's it for now. We'll be back later today to do some more computer science and finish up this unit and get into the next one. So talk to you in a bit. Alrighty. Let's finish up computer science for the day. What were we doing earlier? Print functions. What was after that? Parameters? Something with parameters? Alright, come on. What was it about? Something to do with functions. Typing. Dynamic and static typing. Alright. I'm going to continue net learning now, and then I'll be back to recall what I learned in a little bit. Alright, we finished the unit on dynamic typing. No more notes from that, but we started and finished the next unit as well, which was on benefits or reasons to use functions. First reason was improved readability. It makes the main program a lot easier to read and understand. It's actually a key skill that makes a good programmer. The skill being writing logical and understandable programs using functions that are clear, logical, intuitive. General rule, we'll say number 2. So first was improved readability. Second was modular development. And this modular development is like programming, a programming approach where you build a program basically like incrementally, module by module, modular development. And this helps with just development, smoothness of development, less errors, kind of like laying the map or the plan out and then getting into the details. And then the third benefit or reason to use functions is eliminate redundancy. So yeah, functions can slow down the program just a tiny bit, and also can lead to having more lines, but the trade-offs are better for readability and development and fixing and improving and adding on more parts. Okay, 15, or the next unit was mathematical functions. So mathematical functions are functions that basically, they said involve multiple numeric inputs or parameters, but I don't know if you need to have necessarily multiple, but it does have mathematical operations and returns some kind of numeric value based on mathematical operations within the definition of the function or the main body or the statements on the with the parameters somehow being involved, the arguments somehow being involved. Reasons for defining functions: improve program readability. Second, modular program development. Modular development, the process of dividing a program into separate modules that can be developed and tested separately and integrated into a single program. Avoid writing redundant code. The skill of decomposing a program into good and easily understandable and logical functions / modules is a key skill that makes makes someone a good programmer. Generally, our general guide for beginners is to have less than 30 lines within a function definition. That's just a general rule, not strict, but just guideline. Mathematical function. A function involving several numeric parameters and returning a numeric result. All right, simple enough. So that's actually the final unit within lecture 18, so we'll probably finish that tomorrow. Yeah, I definitely should. We'll see. We have class, so but good chance we finish that lecture tomorrow. So that's due Tuesday, so we got some time. That's it for today. Talk to you tomorrow. See you.